Hey folks, welcome to Flemdog Tutorials. Today we'll be doing stoichiometry. We'll be looking at aluminum reacting with lead chlorate to produce lead and aluminum chlorate. So let's start that out and see how we do. So our problem, let's start with 5A here. It says we have 7.68 moles of aluminum. How many moles of aluminum chlorate will you produce? Okay, so step one, whenever I look at an equation, is see, is it balanced? And this one is not. So I wrote it down here. Let's balance it. You'll want your periodic table eventually. So I got mine here. If you don't got yours, get yours. And also get your trusty calculator. You'll need that too. So let's begin. All right, so step one, let's go ahead and balance. We got aluminum and aluminum, that's 1 to 1. We got lead, that's 1 to 1, so that's looking good. But then we have 4 chlorates and 3 chlorates, and that is not balanced. So what we need to do is find the first number that 3 and 4 go into. And remember, this 4 is referring to this whole group of ClO3, so 4 of those. So the first number 4 and 3 go into is 12, which means I'm going to need 3 groups of this 4. 3 times 4 is 12. If you'd like to see more on balancing, just check out our balancing equations. You can get some more practice there. And this one I have 3 of, so 3 times 4 is going to go right there. Now I can balance the rest. I have 3 leads. This means I have 3 of everything that comes after. So 3 leads and then 3 groups of 4 chlorates. So 3 leads, let's put that 3 right there. And then over here, I have 4 aluminums. So over here on my reactants, I'll put 4 aluminums. That should be all balanced. 4 aluminums, 3 leads, 3 leads. 4 times 3 is 12 chlorates, and 3 times 4 is 12 chlorates. So step one, we're all good. Next step, let's look at what our problem gives us in terms of information. We got 7.68 moles of aluminum. Now, when I like to do these, I'm going to set my blue aside, get a different color here. I put them in columns like this. This helps me keep track of the units that I'm looking for. So we're going aluminum here. So our problem tells us we got 7.68 moles of aluminum. So where do you think we're going to put that 7.68 moles? We're going to put it in the aluminum column here. So 7.68 moles of aluminum. And it says how many moles of aluminum chlorate. So we're going over to aluminum chlorate, AlClO3, and how many moles will we have there? Will you produce? So produce, that tells us we're looking at products. How do we do that? What I like to think about is every time, get back to my blue here, every time I have to cross one of these green lines when I go from one thing to another, doesn't matter if it's reactant to reactant, reactant to product, product to reactant, product to product, whatever it is, anytime I cross one of these lines, I need to get to moles. So moles is how I cross from one thing to another. And in this case, we see that I'm in the mole. So moles can cross us into something else, which is moles here. I might say that anytime you take a voyage doing stoichiometry, you ride the most noble beast of all, the mole. So we take this voyage on the mole, and this, we're in moles, going to moles. So my little rule is I use going moles over from moles. And this is the only time that you use these numbers that you use to balance here. When you're crossing the line, it's the only time I use the 4, the 3, and the 4 when I cross a line. So here I'm crossing all the way from aluminum over to my aluminum chlorate. So the thing that I'm going to is 4. So I put a 4 right there. And I'm coming from 4. So I put a 4 right here. So it's going to be 7.68 times 4 over 4. Put a little multiply right there. And what's 4 over 4? That's just 1. So 7.68 times 1 is going to give us 7.68 moles of aluminum chlorate. Now, if you're showing the math on that and you're required to show perhaps more than this, which I require of you if you're one of my students, is we need to show 7.68 moles of aluminum over 1. And we can use this fun little technique here where we just put a little line. And our first thing we want to do is always bring the units down. And our units here are moles of aluminum. So I bring down moles of aluminum. And I say that I'm going to moles of aluminum chlorate. So I'm going to put moles of aluminum ClO3, 3 moles of aluminum chlorate. And now I need to put the number that's in front of those. So in this case, my moles of aluminum is 4. So I'll put a 4 right there. And my moles of aluminum chlorate, in this case, would be 4 also. That's the number in front of aluminum chlorate. So I put a 4 right there. So multiply everything on the top, divide by everything that's multiplied on the bottom. And again, we have this same 7.68 times 4 over 4, but our moles have canceled and we're left with moles of aluminum chlorate, which is exactly what we have right there. So here's how you can show that work. Let's do another one. Feel good on that? If not, do it again. I think a great little trick that I've learned is once you do a problem, do it with a little guidance possibly, and then do it again. Make sure you can do it by yourself. And this problem, I would say, if you can do it well, it should take you like 60 seconds or so, maybe 2 minutes, but not a super long process. Our next one, I'm just gonna fold this under like this. Now, let's do one more. What's our final one? These just get a little harder each time. So this one will be a grams to grams. Here it is. We have 6940 grams of lead chlorate. How many grams of aluminum chlorate will you produce? So this is going to be our products, aluminum chlorate. This is what we start with. Those are our reactants. Let's put our columns in and see how we do here. So I'm going to make my column that I'm going to do just a little bigger. So I'm using this one, and then I'm going to use, I think it said my, let's check, aluminum chlorate. Yeah, using my aluminum chlorate here. So I'm going to make my lead column pretty small. Great. Now we have 6940 grams of lead chlorate. So underneath lead chlorate, let's write 6940 grams. So that's 6940 grams of lead chlorate. And then I'm going over to here, and it wants how many grams of aluminum chlorate will you produce? So let's put a question mark, grams right there. So conceptually, what are we going to do here? And then we'll figure out how to do this. I'm going to take grams into moles. How will I do that? I will divide by the molar mass. Then I'm going to make the great journey across the lines. Whenever I do that, I use my balancing numbers. That is going to be my going over from. So we'll get that mole ratio. And that will get us from moles of lead chlorate into moles of aluminum chlorate. And then we have to get to grams. So to get to grams, we're going to multiply by the molar mass. And a quick little conceptual guy here. Let me put this right here so you can see it. So if you're going from moles to grams, just so you kind of see this, whenever you go moles to grams, you're going to multiply by the molar mass. Grams to moles, you're going to divide by the molar mass. So that's like a easy little conceptual you can lean back on sometimes if you get stuck. Now let's go ahead and solve what we need. I oftentimes like to just put the molar mass of everything on the top. I won't here just to save us a little time, but we need to find the molar mass of lead chlorate. So lead is our 207. We wrote that down here, 207.2. Chlorine is 35.5. And I'll jot that down, 35.5. And that was right here, 35.45, which rounds to 35.5. And then oxygen is 15.999, which will round to 16.0. Right there. And we do have 3 of those. So that's going to be times 3. So we have 35.5 plus 16 times 3, but then we have 4 of those. So we multiply all of that by 4. And then we need to add our lead, which was 207.2.2. Yeah. Great. So what does that molar mass come out to? Let's plug that in. See what we get. 207. Oh, try that again. 207.2 plus, do my brackets here, 35.5 plus 16 times 3, close that bracket, and we need to multiply it by 4, so times that by 4, 541.2, unless I screwed that up. So molar mass, 541.2 grams per mole. And then this one right over here, we're looking at our lead chlorate. Aluminum, I don't think I did that yet, so let's find that, buddy. 26.98, which we can round to 27.0. So this one, 27.0. Chlorine, or we just said was 35.5. Oxygen, we just said was 16. And we do have 3 of those, so let's multiply that by 3. But then we have 3 of our chlorine and 3 oxygens, so let's multiply that by 3 and add those together. And we can see what that molar mass comes out to. Okay. So that gets us 27 plus 35.5 plus 16 times 3. I wonder if you can hear these children outside. They're having so much fun. I want to go outside. When we're done, everyone goes outside and plays. 277.5 and that's grams per mole. All right, we're all set up to do this problem now. Let's plug in the things that we got. So these numbers, my molar masses, I write them right here by saying 541 grams. I should have put 0.2. Let me do that. 541.2 grams for every 1 mole. And this one right over here, we have 277.5 grams for every 1 mole. Now I'm ready to do the math. Okay, so we could, again, just plug in. I oftentimes like to just get my answers and then go through and show my work after. So for this one, when I'm going from moles to moles, this is when we need to look at our molar mass. And in this case, what are we going to? 4. And what are we coming from? 3. So I put a 3 underneath right there. So let's plug in our values. We'll get our answers real quick, and then we'll show our work with stoichiometry, how we do that. So 6940 divided by 541.2 equals 12.8 moles. So there's 12.8 moles of lead chlorate. Now, how many moles of aluminum chlorate are there? Let's take our 12.8 and multiply it by 4/3. So 12.8. I don't know what I just had. Let's start here. 12.8 times 4 divided by 3. 17 point, I'll just round up to 1. 17.1. 17.1 moles. So this is how many moles of aluminum chloride I have. So what mass is that? Our final answer that we're looking for, 17.1 times 277.5. So times 277.5 is 4736. And this is grams of aluminum chloride. So that's how you can do it, just quickly using conceptual. Now, how would I show my work doing that? I would do this. Again, this is kind of fun when you don't have to just do the conceptual. I think it takes a little bit maybe for it to be fun, but I've started to enjoy it now. 6940 grams, and that is of lead chlorate, PbClO3, 4, and we put that over 1. Now, we're going to need to do 1 step, 2 step, 3 steps. So I'll just leave some space here. So my next step, we always just bring our units down right there. So lead chlorate, grams goes down. That's what we're going to need to cancel, is grams of lead chlorate. So grams of PbClO3. There's 4 of those right there. So how do I cancel that? Well, I'm going to moles of lead chlorate. So moles of PbClO3, 4. And what numbers go in front of the moles and the grams? Whenever you see moles and grams when you're canceling, that is a molar mass, whether it's grams on top, moles on the bottom. But moles and grams, that tells you molar mass. So let's go to right here, and I did that one in blue, so I'll write that down in blue. 541.2 grams. So my grams right here gets 541.2. My moles, the number in front of moles is 1, so I put a 1 right there. And that canceled grams of lead chlorate with grams of lead chlorate, so all of that gone. Now I'm in moles of lead chlorate. I'm to right there. But we need to get from here to there. How do we get from here to there? Molar ratio. So this is our molar ratio. Molar ratio. And this now, this is going to be, we know our numbers, 4/3. So I'll just jot that down, 4/3. So what does that 4/3 mean? The 4 is my aluminum chlorate moles. So 4 moles of aluminum ClO3, 3. And the 3 is the one that I'm canceling right here. So if I brought this unit down, that is my moles of lead chlorate. Moles of lead ClO3, 4. Moles of lead chlorate. All right, so that cancels moles of lead chlorate with moles of lead chlorate. And now I'm in moles of aluminum chlorate. So moles of aluminum chlorate. My final step, kind of ran out of room here, but my final step is to get from moles of aluminum chlorate, put that here, moles, aluminum, ... chlorate, and we need to get that to grams of aluminum chlorate. So grams of aluminum, ... chlorate. Okay, so where are we at? What do we need to do now? look at our units, moles and grams. Whenever you see moles and grams, that tells us we're talking about molar mass. And molar mass here, we have 277.5 grams. So in front of grams, that's going to be our 277.5. 277.5. And in front of moles, we have 1 mole. 1 mole. So we see we just multiplied by molar mass because the molar mass is on the top. And if we plug all of that in, I could show you how to do that just to make sure we don't miss some simple step that you're not sure how to do here. So we plug all this baby in. 6940 divided by 541.2, divided by 541.2. That got us into moles of lead chlorate. Now we need to get across to moles here. So we multiply by 4 over 3, multiplied by 4, divided by 3, 17.09. Now we're in moles of aluminum chlorate. Now we need to get from moles aluminum chlorate to grams. So we're going to multiply by 277.5 because it's on the top. So multiply by 277.5 and voila, there we are, 4744.6. And we put down 47. We rounded a little bit early on, so our number's slightly different, but same one if I had not rounded my first number. I think I rounded this one right here if I remember correctly. Anyway, I hope that helps. That's how you do these stoichiometry ones. I like to, again, balance, show my conceptual steps. Remember that I always have to go from moles to moles of something else. You cannot go from grams to grams or grams to moles, always moles to moles. And the way you get from moles to moles is the molar ratio. And the molar ratio comes from the balanced numbers in front of the equation. I hope that helps you, and we'll try another one again soon. See you soon. Wonder, oh wonder.